Everyone. Today we'll have the marathon class of the chapter Permutation and Combination. First, we'll discuss the basic concepts of permutation and combination. We'll try out every variety of some one of each kind. And then we'll solve the past year questions like we did in the Mathematics of Finance chapter. Now, the topic permutation and combination basically comes from the topic of counting. In counting, we first talk about two fundamental principles, addition and multiplication. We add when there is a or. We multiply when we say and. So for or, we add, and for and, we multiply. So if I say fill this position and this position and this position, so I'll multiply the individual option. And if I say I'll have either this answer or this answer, I'll add the individual option. So whenever you're calling out or you're doing the sums, always call out about individual options. And then you see that whether each of these position has to be filled up together to do the entire work, or some of them can be filled up and the work will be completed. If it is that no, all of them should not, it's not necessary to choose everyone, or it is not necessary to fill out everyone, then you do addition. And if it is completely important that each and every position, each and every option has to be chosen, then you multiply. That's the first and primary principle. Then the first part we do it is without any formulas, that is just common sense. For example, if I have all the English alphabet letters, there are 26 English alphabets. Out of that, we have 5 vowels, A, E, I, O, U, and rest of them are 21 consonants. Suppose I want to form a 5-letter word. I want to form a 5-letter word. So suppose I just say that form a 5-letter word, there's no restriction written. So then I have to fill up each and every position. And if nothing is mentioned, it is without replacement. That means each letter can be used only once. So the first place can be filled in 26 ways, then 25 because one of them is already used up, then 24, then 23, and then 22. So in order to form a 5-letter word, each of these positions has to be simultaneously filled. So we multiply. Okay, because it's and. First place has to be filled, and second has to be filled, and third has to be filled. So for and, we use the symbol of multiplication. Clear? Now in the same sum, if I put up restrictions, in the same sum, if I put up restrictions, for example, your word should start with a vowel. The word should start with a vowel. Then we first think about the first position which has a restriction. So the first place has to be filled up by a vowel. So there are how many vowels? There are 5 vowels. So the first place can be filled by any one of the 5 vowels. One of them sits here. Now there is no more restriction on the rest of them. So out of 26, one of the vowel is already used, remaining 25 letters, and now the remaining portion has no bhetap. They are not doing any partiality. Anyone can sit at any place. So the second place can be filled in 25, 24, 23, 22. All of them have to be filled up simultaneously to get a 5-letter word. So we multiply. Now, the same question can again have another restriction. In how many ways can you form a word so that vowels sit in the first place and consonants sit in the last place? So now there is a restriction on both the first place and the last place. So we have to think about both the places. Now the first place has to be filled up by a vowel. So the first place has how many options? 5 options. Now there is a restriction in the last place. The last place has to be filled up by a consonant. So there are 21 consonants. So there are 21 ways to fill this. Now there is no more restriction. So out of 26 letters, one of them has sat in the first place. One of them sits in the last place. So those two are done. So remaining 4 options, remaining 4 places, 3 places. Those 3 places has no more restrictions. So anyone can sit. So how many letters are remaining? 2 are used. So remaining is 24. So the second place has 24 option, 23, 22. All of them will be multiplied to get all the words. Suppose it is said that the vowels occupy even places. Same 5-letter word. The vowels occupy even places. So, and consonant occupy odd places. So, how many even places are there? Only 2. The second and the fourth position are the even position. And in these 2 positions, only vowels will be sitting. So the second place has to be filled up by a vowel. There are 5 vowels. One of them sits here. The fourth place is also filled up by a vowel. So remaining 4 vowels. So 2 letters are done. 2 letters are done. Then we have 21 consonant. None of them has been used up till now. The first place will be filled up by a consonant. 21 option. The third place, again odd place, will be filled up by a consonant. The last place will again be filled up by a consonant. 19 place. Clear? So to fill up the form of 5-letter word, I need all of them. So we multiply. Any doubts?
मैम
Yes.
I'm sorry मैम टेस्ट लिख रहा था अभी कर रहा है
No,
on
I just started the first.
okay मैम thank you.
Then we have for words also, numbers also. Suppose I have 1, 2, 3, 4, 5, 6, 7. I have 7 digits. In general, how many digits are there in a number system? There are 10, 0 to 9. If 0 is included, it changes the entire scenario. We first do this where there are 7 digits. So now I need to form a 4-digit number. So to form a 4-digit number, each of these places has to be filled up simultaneously. So I'll find the individual options and then multiply them, right? Because it's not a situation of or, it's a situation of and. So now there is no restriction and you just need to form a 4-letter word. If I don't mention anything, then 1 digit can be used only once. So first place can be filled in 7 ways, next 6, then 5, then 4. And we multiply each one of them. Now, if I want an even number, so even is judged by the last place. If in my last place there is 0 or 2 or 4 or 6 or 8, it is directly considered to be an even number. From my given choices, which is 1 to 7, if I want my number to be even, then in my last place, in the units place, either 2 has to sit or 4 or 6. Any one of the 3 option has to be here. So the last place can be filled in 3 ways. One of them sits here. There is no more restriction. So out of 7, I have used only 1. So 1 option done. Remaining 6. Rest of them can sit anywhere. So I have 6 options, then 5, then 4. You multiply, these many even options are there. To get odd, you can do total minus even also. That is also an option. Or we can think again. If I want an odd number, so the last place has to be filled by 1, 3, 5, or 7. So the last place has 4 options. One of them is used up. Remaining 6 digits. So first place 6 option, then 5 option, then 4 option. Here, I want a multiple of 4. For a number to be a multiple of 4, the last 2 digit has to be a multiple of 4. And I have to think of them as a 2 digit. So I have to think of these 2 places together. So these 2 places have to be filled up by a number that is a multiple of 4. And in that, I can only use 1 to 7. So from these 7 digits, first I will think that how can I form a 2-digit number which is a multiple of 4. So I have 1 to 12, 13, 14, 15, no. Then 16, 17, no. Starts with 2. 21, no. 23, no. 24. Then 3, 32 and 36. 4, I don't have an option. Then 52 and 56. I don't have 2 4s, no? Then 64, 72, and 76. So in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have in total 10 numbers who has to be one of them who has to sit in the last 2 place. Either my last 2 place has to be filled by 1 to 12, or my last 2 place has to be filled by 1, 6, 16, or my last 2 place has to be filled by 2, 4, 24. So the last 2 places can be filled in 10 ways together. I cannot think of them individually while talking about a multiple of 4 or divisibility by 4. So 10 options are there to fill the last 2 positions. One of them will be chosen. So 2 digits are gone. Out of 7, 2 digits are already used. Remaining 5 digits. So first place 5 option, then 4 option. So 5 into 4 into 10. Any doubts?
No, ma'am.
No, ma'am.
No, ma'am.
Now, in the same sum, you have 0, 1, 2, 3, and 4. I want to form a 3-digit number. Now, even though there is no restriction, but since in our given option there is 0, there is an inbuilt restriction. The first place can never have 0. Because if 0 is sitting in the first place, it will no longer be a 3-digit number, it will be a 2-digit number. So the first place cannot be filled by 0. It has to be filled either by 1 or by 2 or by 3 or by 4. So the first place has 4 options. One of them sits here. Now from 5 options, one of them is sitting here. The remaining 4 options are there. In the remaining 2 places, 0 is allowed, right? So the next option 4 and then 3. If I want an even and an odd number, it's easier to think about an odd number. For an odd number, the last place has to be filled by 1 or 3. So there are 2 options to fill the last place. One of them is sitting here, remaining 4 options. Okay, in that 0 is there. But 0 cannot sit in the first place. So 3 options are there. Again, there were total 5. One of them is sitting in the last place. One of them is sitting in the first place. 2 are gone. Remaining 3. So 3 options here. Clear? So in total, there are 48 numbers. Out of that, 18 are even. Odd. So automatically for even, you can subtract 30 numbers will be even. Am I clear?
Yes, ma'am.
All of you clear? Then we have
Yes,
certain
ma'am.
scenarios like I have 5 letters and 4 mailbox. I have to post the letters. I have to post the letters in the mailbox. So it is always mailbox to the power letter. The formula is mailbox to the power letter. Basically, you think about how can I post them. First letter. In my hand, I won't have a mailbox. In my hand, I'll have a letter. I pick up the first letter. First letter can be posted in 4 ways. I pick up the second letter. Second letter can be posted in 4 ways. Mailbox can have more than one. Third letter. Third letter can be posted in 4 ways. So there will be 4, 4, 4, 5 times. So answer is 4 to the power 5. But if the question says, in how many ways can you post 5 letters in 4 mailbox? All of them should not be in the same ways. All of them should not be in the same ways. So that case, it will be total options minus all in one box. So total is 4 to the power 5. All in one box. It can so happen that all the 5 letters are in the first box. All the 5 letters are in the second box. All the 5 letters are in the third box. All the 5 letters are in the fourth box. So those 4 possibilities are not allowed. So basically total option minus the number of boxes. Minus answer will be 1020. Am I clear?
Yes, ma'am.
Ma'am.
Yes,
Yes,
ma'am.
Then supposingly in a room there are 10 bulbs, 10 lights. In how many combinations are there? Every light has 2 switches, either on or off. So first light 2 option, second light 2 option, third light 2 option. Each of the 10 lights will have 2 options each, and you are thinking about all of them together. So it's a case of multiplication. So 2 will be multiplied 10 times. So it is 2 to the power 10. Now again, in how many ways can you have 10 bulbs in a room so that the room has some light or the room is illuminated? So if I want light in my room, then at least one of the light has to be on. That means I don't want the case where all of them are off. How many ways are there to switch off everyone? Only one. First bulb off, second bulb off, third bulb off. So 1 raised power 10. So from the total, remove dark option. So dark option is how much? Only one. There is only one way in which you can have darkness in them, in which you can have zero light in them. I only have a problem with that. Even if you own a lampshade, it's fine. So what I want is basically total option. Each bulb has two options, either on or off. So two options, second bulb, two options, third bulb, two options. So 2 comes 10 times, 2 power 10. Minus the cases when there is no light in the room. So if I don't want light in my room, all of them has to be off. So all the bulb will have only one option. So for darkness in the room, there is only one way. So from the total, we remove that one way. Am I clear? Suppose there are 5 MCQ questions. If nothing is mentioned, that means all of them has 4 options each. In how many ways can I answer 5 MCQ questions? That's a question. In how many ways can I answer 5 MCQ questions? First question, 4 options. Second question, 4 options. Third question, 4 options. So 4 will appear 5 times. So answer would be 4 to the power 5. Am I clear?
Yes, ma'am.
In how many ways can I answer 5 MCQ questions so that all are correct? Can you tell me, in a question there are 4 options. Out of those 4 options, you also appear the paper, right? I give you 4 MCQ questions. Out of those 4 MCQ questions, how many correct options are there?
One.
1. And how many wrong? 3. So now if I want all the questions to be correct, so for me to write the first question correct, I can choose how many options. There is only one correct option to be chosen. I want the second question to be correct. How many options are there? Only one. Third question correct. Only one. Fourth correct. Only one. Fifth correct. Only one. And all of them has to be correct. A situation of and. So 1 is multiplied 5 times. So I'll have only one way of securing 5 out of 5. There is only one way of getting 5 out of 5 questions correct. Question number 3. All are incorrect. All are incorrect. All are incorrect. All are incorrect.
3%.
Very good. All of you. First question incorrect, 3 options. Second question incorrect, 3 options. Third question incorrect, 3 options. 3 will appear 5 times. So 3 to the power 5. Not all are correct. That means what I want is all of them should not be correct. I can have 1 correct, I can have 2, I can have 3, I can have 4, but I cannot have 5 correct. So rather than thinking about how can I have 1 correct answer, how can I have 2 correct answer, how can I have 3 correct answer, rather than that we do total minus all correct. That is the only case that I have a problem with. From all the total cases, remove the case when all the questions are correct. That is the only problematic thing for me. So total, I have 4 to the power 5 options. From that, I need to remove the case when all of them are correct. So all the questions are correct. There is only one way. Subtract that. I don't want not all are wrong. Again, same. I don't want all 5 wrong. I can have 4 wrong. I can have 3 wrong. I can have 2 wrong. I can have 1 wrong. I can have no wrong. But I cannot have all 5 wrong. So from total, remove the case when all are wrong. So total 4 power 5. All wrong 3 power 5. Any problem?
No, ma'am.
So First, this is the case where we use addition and multiplication and basic principles. No formula, nothing, pure common sense. Clear?
Yes, ma'am.
Now we'll move on to the formula part. For formula, we first learn factorial notations. Okay. So what is factorial notations? This is the symbol or this is the symbol. It says multiply all natural numbers till n. Multiply all natural numbers from n till 1. So when I open a factorial, first the number comes itself, then a number smaller than that, n minus 1, and again smaller than that. And you keep on multiplying till you get 1. So when you open n factorial, there are n factors. So when we open 4 factorial, it will be 4 multiplied by 4 minus 1, 3, multiplied by 3 minus 1, 2, multiplied by 2 minus 1, 1. So there are 4 factors, which is 24. Or what can I do is, I can open the 4 factorial, so it gives me 4. Then what can I do is, rather than opening them up, I can write 3 factorial. What I can also do is, I have opened 4, then 3, and then I can write 2 factorial. Can I do that?
Yes, ma'am.
Suppose I have factorial 10 by factorial 8. Whenever we are simplifying the factorials, we open the larger factorial till we get the smaller factorial. Out of 10 and 8, 10 is larger. So I'll open the factorial of the larger number. So 10 factorial, the first number is 10. Then 10 minus 1, 9. Then 9 minus 1, 8. As soon as you get 8, you can write factorial here. They get cancelled. Answer would be 9. Am I clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Clear? Suppose I give you n divided by n minus 2. If you're not sure about which one is larger, put any value of n. If you put n equal to 5, numerator 5 factorial, denominator 5 minus 2, 3 factorial. So the larger one is numerator n factorial. So you'll open n factorial till you get n minus 2. So first is n itself, then minus 1, then again minus 1. You get n minus 2. This is where I need to stop. And if this was given to be 60, then you can do trial and error. It can be 60, say 30. Am I clear?
Yes, ma'am.
Now remember that factorial 0 is 1. Memorize this. Factorial 0 value is 1. Rest you all can calculate. Can you tell me which factorial is 5040? If I want to find a number in terms of a factorial, what we do is we start dividing the number. You have calculator. Divide the number by 2. Divide the number by 2, 2520. Then divide by 3. Serial order. Then divide by 4. Then divide by 5. Then divide by 6. So we get 2, 3, 4, 5, 6, 7. Serial order. The largest number is 7. So this is basically 7 factorial. You can compare and write that n is equal to 7. We can compare and write n is equal to 7. Clear?
Yes, ma'am.
Yes, ma'am.
Yes. Suppose I have a question. X divided by factorial 10, 1 by factorial 9 plus 1 by factorial 8. You can do trial and error or send factorial 10 to the right side. It will go to each and every number. Now, simplify this. Simplify this.
Hundred.
So 10, then 9 factorial gets cancelled. Here I'll open the larger factorial 10, then 9, then 8. So this will be 10 plus 90, that is 100. Any doubt?
No, ma'am.
No, ma'am.
All of you clear? After factorial, we talk about permutation and combination, the actual chapter. When we talk about permutation and we talk about combination, since I've already done the chapter, I'll treat them together. Permutation will be used when we need to select as well as arrange. Also in situations of only arrangement. Basically, arrangement has to be there. Whether or not selection is there, that is irrelevant. If we are using combination, I'm only doing selection. I'm not bothered with the arrangement, not bothered by position. That is 2, 1 and 1, 2 is same. But if they matter something else, like in case of a number, 21 is a different number, 12 is a different number, I'll use permutation. So when you are selecting, only selecting, use combination. When you're doing both, use permutation. When you're only doing arrangement, you can use permutation or we can directly use factorial. Any doubts still here?
No, ma'am.
Okay. Formulas Pn, R or NPR. Formula factorial n upon factorial n minus r. Now, n and r are both whole numbers 0, 1, 2, 3, 4 and value of r is 0, 1, 2 up to n. It cannot go beyond n. Here, Cn, r or NCR. Factorial n minus r, factorial r. Same, n and r are both whole numbers and r cannot go beyond n. Okay. Now remember here when you divide, see here. When you divided 10 and 8 factorial, how many factors did you get? 10 and 9, 2 factor, only 2 factors you got. See, when I'm going to open, for example, 5p3, factorial 5, 5 minus 3, 2 factorial. I'll open 5 factorial, 5, 4, 3. 2 factorial gets cancelled. So when I opened 5p3, how many factors did I get? I got 3 factors, right? So when you open NPR, there will be R factors. There will be R factors. If you are opening 10p6, there will be 6 factors. If you are opening 10p2, there will be 2 factors. If you are opening 5p3, there will be 3 factors. If you are doing 5p0, there will not be any factor. If you are doing 5p2, that is 2 factors. Am I understood?
Yes, ma'am.
Clear?
Yes, ma'am.
Then there is a formula that gives you a relation between permutation and combination. NPR divided by NCR is factorial R. NPR divided by NCR is factorial R. For example, if I say NPR is 720, NCR is 120, find R. You divide them. NPR divided by NCR is factorial R. This is 6. So can you say 6 is the factorial of which number?
3.
This is 3 factorial. If you're not sure, divide 6 by 2, 2, 3. So R would be 3. Clear?
Yes, ma'am.
Yes, ma'am. Yes.
All of you clear?
Yes.
Okay.
Mm.
Then in case of permutation, we form words continuation. We form numbers. We give awards. We give position, treasury, and all those things. When it comes for combination, all geometry, circles, lines, diagonals, parallelograms, rectangles, all geometrical figures comes in combination. Handshake, team formation, everything comes under combination. All geometrical figures comes under combination. Forming a team, selecting a few people, forming a committee comes under combination. Clear? All of you clear till here? When we are doing
Yes, ma'am.
permutation, if it is NPR, for example, 10P3, this means select 3 people out of 10 and then arrange the 3 people. So when you use permutation, we are basically doing first selection and then arrangement. But if your job is only to arrange, suppose arrange 5 people. Do I need to select? No, my job is only to arrange. Then you can directly write 5 factorial. If I have to arrange 10 people, I can directly write 10 factorial. If I have to arrange 3 people, I'll directly write 3 factorial. If I have to only select, use combination. Out of 10, choose 3 people, 10C3. Out of 10, choose 3 people and then award them. It is permutation, 10P3. You have already selected the people, you only need to arrange them, 3 factorial. For only arrangement, we directly write factorial. So for example, if you tell me, I have 1, 2, 3, 4, 5, and I want to form a 5-digit number. I want to form a 5-digit number. You can do by common sense also. And since here, if we know that, do I need to make a selection here?
No, ma'am.
No, my job is only to arrange. So out of 5 digits, I only need to arrange them. So I can directly write 5 factorial. It starts with an even number. Starts with an even number. There's a restriction in the first place. First place has to be filled by 2 or 4. There is 2 ways to fill this position. How many letters are used? Only 1 letter is used. How many are left? 4. Do I need to select now? No, I only need to arrange them. So I can directly write 4 factorial into 2. So when I only need to arrange, you can directly write 4 factorial, 3 factorial, 2 factorial. If you have to select and arrange, then use P. Am I clear?
Yes, ma'am.
Yes, ma'am.
Now we form questions for, say, in case of permutation, what varieties of questions do we encounter? First, we talk about words which has no repetitions. Suppose I have the word equation. No repetitions. I have how many letters? 8 letters. In these 8 letters, there are 5 vowels and 3 consonants. How many words can be formed? How many words can be formed out of 8 letters? So, how many words are there? Out of 8 letters, do I need to make a selection?
No, ma'am.
If I haven't said anything, all the 8 letters have to be used. So, my only job is to arrange. So, directly 8 factorial. Starts with a vowel, ends with a consonant. So, the first place has to be filled up by a vowel. The first place has to be filled up by a vowel. So, first place has 5 options. The last place has to be filled up by a consonant. So the last place has 3 options. So out of 8, first and last place is filled up, 6 position left. Out of 8 letters, 1 letter sits in the first place, 1 letter sits in the last place, 2 are gone. So now the remaining 6 letters, do I need to make a specific selection? No, my job is only to arrange them. So those remaining 6 letters can be directly arranged by 6 factorial.
Yes, ma'am.
Yes, ma'am.
Vowels are together. As soon as we hear the word together, form the bundle for whichever whichever part you want to be together. I want the vowels to be together, form a bundle. So what I'll do is I'll consider the 3 consonant and this bundle. So in total, I have now 4 things. I have to arrange them. So 4 things, 4 letters can be arranged in how many ways?
4 factorial.
Arrange. Now I consider them to be bundle. They have to be together. But within the bundle, within being together, they can arrange among themselves. So 5 vowels can arrange among themselves in how many ways?
5 factorial.
5 factorial.
Multiply. If I want consonants to be together, together means all together. All the consonants are together. All the consonants are together. So what do? We form a bundle for the consonants. So 5 vowel and this bundle becomes 6. 6 letters can be arranged in factorial 6 ways. The remaining 3 consonants which were there in the bundle. So among the bundle, they can be arranged in how many ways? Factorial 3 ways. Yes?
Yes, ma'am.
Yes, ma'am.
All 5 vowels are not together. All are not together. Whenever you see the word all are not together, it is always total minus together. So total was factorial 8. Together means vowel together. This is what I had a problem with. So vowel together was how much? Factorial 4 into factorial 5. Clear?
Yes, ma'am.
Yes, ma'am.
All of you clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
How many words will have ON? How many words will have ON? That means ON has to appear together. So what we do is we form a bundle of ON and there are 6 more letters. There are 6 more letters. So those 6 letters and this bundle form 7. So 7 letters can be arranged in how many ways? Factorial 7. Factorial 7 ways. Now, within the bundle, I had O and N. Do I need to change their position? Am I allowed to interchange them?
No, ma'am.
No, I want ON as in the same position. So in this case, the bundle won't rearrange. So the only answer is 7 factorial. Clear?
Yes, ma'am.
Consonants occupy odd places. So out of 8, how many consonants are there? 3 consonants. Okay. This will come. Okay, let's do. Consonants occupy odd places. There are 3 consonants. Okay. And how many odd places are there? First, third, fifth, seventh. There are 4 odd places and there are 3 consonants. Yes or no?
Yes, ma'am.
So
Yes,
out
ma'am.
of 4, I need to first select the 3 places where the consonants will sit. And once you have selected the consonant, you also need to arrange them. So it is selection plus arrangement. Whenever there is selection plus arrangement, what do we use? Permutation. So out of 4, I need to select 3. And then I need to arrange the selected 3. So 4P3. So I have used 3 letters. I have occupied 3 places. How many letters are left? 5 vowels. How many places are left? 5 places are still left. Now do I need to make a selection? No. My only job is to arrange those 5 vowels in those 5 positions. So 5 letters can be arranged in how many ways? Factorial 5 ways. Clear?
Yes.
Yes.
Yes, ma'am.
Any doubts?
No, ma'am. No, ma'am.
I have 4 boys and 4 girls. I'll give you questions, you try. Arrange them in a line. All girls together. All girls are not together. Not, no 2 girls are together. Alternate. Boys and girls alternate. Try. The first question. Answer. 4 girls, 4 boys, arrange them in a line.
Factorial
8 people have to be arranged. No selection necessary. So 8 factorial. All the girls are together. So whenever we are talking about together, we form a bundle. So 4 boys and this bundle is 5. So 5 people can be arranged in 5 factorial. Within the bundle, there are 4 girls. Those 4 girls can be arranged in 4 factorial ways. All girls are not together. This will be total minus all girl together. This will be factorial 8 minus the second one. Till here, any doubt?
No, ma'am.
No 2 girls are together. That means I have a problem with any 2 girls sitting together. That means between 2 girls, there should be a boy. Do I have a problem with 2 boys sitting together? No. 2 boys. See, this can happen. This can happen. This is allowed. But girls being together is not allowed. So it's not alternate. Option 4 and 5 are not same. Okay, I have a problem with only girls sitting together. I don't have a problem with boys sitting together. So first we make the 4 boys to sit together. 4 boys can sit in how many ways? 4 factorial. So boys, 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 boys. Now for the girls to remain away from each other, they can sit in these gaps. How many gaps are there? 5. But we need only 4. So out of 5, I need to select 4 places. And then in those selected 4 places, I need to arrange. So I need to first select and then I also need to arrange. Out of 5, select 4 and then arrange in those 4 selected positions. So that will be 5P4.
5P4.
Clear?
Yes, ma'am.
Now, alternate. That means I have a problem with boys also to sit together. So, if the boys sit together first, it is 4 factorial. Now, for boys and girls both to be away from each other, the girls can sit in these 4 positions. 4 position, 4 girls. Only arrangement, 4 factorial. Or means plus. Let the boys sit together, 4 factorial. The girls can also sit in these 4 places. 4 places, 4 girls, 4 factorial ways. Twice factorial, 4 factorial. 4 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 factori Am I clear? Any doubts?
Can you show the
No,
answer for
ma'am.
the previous question, ma'am? Yes, ma'am. Got it, ma'am. Thank you.
Question. There are 4 married couples. In how many ways can you arrange them so that the couples will always sit together? In how many ways can 4 married couples sit together so that the couples will always sit together? So 4 couples, that means 8 people, 4 husband, 4 wife, but the couples cannot stay away from each other. So husband, wife, one bundle. Again, husband, wife, another bundle. So consider them as 4 bundles. 4 bundles can arrange among themselves in 4 factorial ways. Now they have to stay together. But it can happen that husband, wife, husband, wife, husband, wife, husband, wife, wife, husband. In this way also they can sit, right? So the couples can have to sit together, but they can arrange left, right among themselves. So C1, C2, C3, C4, 4 couple. 4 couple can be arranged in 4 factorial ways. Now the first bundle is couple 1. Couple 1 can shift among themselves, factorial 2. Couple 2 will also say, I also want to say, who will sit in the left, who will sit in the right. So couple 2, C2, they can also arrange among themselves. Third couple, fourth couple. Am I clear?
Yes, ma'am.
Yes, ma'am.
Question. Number of 4-digit numbers greater than 5,000 that can be formed out of 3, 4, 5, 6. Nothing mentioned, so without replacement, repetition is not allowed. Repetition is not allowed. Done?
Yes, ma'am.
So 4-digit number greater than 5,000. So the first place will be filled by 5 or 6. First place can be filled in 2 ways. One of them sits here, remaining 3, 2, 1 or 3 factorial. Answer is 12. Clear?
Yes, ma'am.
Yes, ma'am.
4-digit numbers out of 0, 1, 2, 3, 4. Again, same, no repetition allowed. Repetition not allowed. So 4-digit number. First place cannot be filled by 0. 4 options. One of them sits. Out of 5, 1 is gone. Then there is no more restriction. So 4, 3, 2, 1. 96 options. Any doubts? Number of ways of rearranging the letters of the word computer.
Eight factorial.
Wrong.
849.
Wrong. See, there are 8 letters, so 8 factorial. No selection necessary. But I said rearranging. That means I don't want computer. I don't want that arrangement. So that particular arrangement I have a problem with. So subtract 1. 40319. Understood? If I would have written arrangement, then answer would have been directly 8 factorial. Clear?
Yes, ma'am.
Yes, ma'am.
10 papers are to be arranged in such a way that best and worst paper are together. Such that the best and worst paper are together. Such that the best and worst paper are together. Ten papers are to be arranged such that the best and worst paper are together. What's the answer? I didn't hear one.
9 factorial into 2 factorial.
Very good. So out of 10, 8 different, those best and worst here, they have to be together, form a bundle. So 8 and 1, 9 people, 9 paper. 9 paper can be arranged in 9 factorial. The bundle can also be arranged. They have to be together. Left, right is not mentioned. So factorial. You don't know the calculation. Clear? Now, if there is repetition, before repetition, there is a learn sum. Learn sum. Sum of all 4-digit number containing the digits 2, 4, 6, 8 without repetition. Formula is if there are n digits, 1, 1, 1 will be n times into sum of digits into factorial n minus 1. So in our case, there are 4 digits. So 1 will appear 4 times. Then sum of the digit 2 plus 4 plus 6 plus 8. Factorial 4 minus 1, that is factorial 3. Multiply them. This will give you the answer. Answer.
120.
Huh? How? Multiply 1111 with the sum. The sum is 20 and factorial 3, that is 6. Multiply this.
133320.
Exactly. 1,33,320. Understood? If I give you the letter 13578, find the sum of the digits. Find the sum of the digits. You can do it directly in calculator. One, two, three, four, five. 5 times 1, that is 11,111. 1 plus 3 plus 5 plus 7 plus 8 multiplied by factorial 5 the numbers, so factorial 4. Answer?
Six three triple nine three six.
Very good. 63,999,936. 63,99,936. Clear?
Yes, ma'am.
Now, if the letters are repeated, for example, again, how many words can we form? So, total factorial divided by number of repetitions. So, there are 2 A's, so divide by factorial. If I have the word mathematics, so total 11 letters. There are 2 M's, 2 A's, 2 T's, and there are 5 single letters. So how many words? Factorial 11. For each repetition, divide by factorial. Am I clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Permutations. How many words? How many words?
12.
Sorry. How many words can be formed by arranging the letters of the word permutations? How many
12
words can be
factorial.
formed by arranging the letters of the word permutations? Waiting. There are 12 letters, so 12 factorial. In that 12, there are 2 T's, so divided by 2 factorial. Is it understood?
Yes.
Yes, ma'am.
Yes, ma'am.
Starts with P, ends with S. Starts with P, ends with S.
10
10
factorial by 2
factorial by
factorial.
2 factorial.
Very good. First place filled by P, only one way. Last place filled by S, only one way. Remaining 10 letters, and there is a repetition of 2 T's, so 2 factorial division. Clear?
Yes, ma'am.
In permutation, the last variety is circular permutation. In circular permutation, you only need 2 formulas. First, Number of ways of arranging n people in a round table, any round table setting. This will be factorial n minus 1. Second, number of ways of arranging n people in a round table so that no person has the same neighbor in any two setting. Or very famous necklace question. Number of necklace. Necklace is always round. Number of necklaces that can be formed with n beads. This will be factorial n minus 1 divided by 2. Half of it. Half of the total answer. So this thing will be specifically mentioned. So in how many ways can you arrange 7 girls in a round table?
6 factorial.
6 factorial. In how many ways can you form a necklace with 10 beads?
9
9
factorial.
factorial by 2.
9 factorial divided by 2. Any doubts? Question. Number of arrangements of 10 things taken 4 at a time, in which first part, one particular thing always occur. One particular thing always occur. Since it is arrangement and out of 10 you need 4, it is selection plus arrangement. So permutation will be used. One thing will always be there. So one position is already filled. And out of 9, I only need that. No. See, first you need to select and then you need to arrange. See, if you do 9p3, there is a problem. You need arrangement also. If you're doing 9p3, those 3 will be arranged among themselves. What about the 4th one? That 4th one also has a say, na? So whenever you need to do such a question, what you do is you first select. You just do the selection first. So from remaining 9, I need to select 3 people. So select them. Out of 9, choosing 3. So that already selected person and these 3 people. So total 4 people. Now these 4 people has to be arranged. So factorial 4. Am I clear? Here you cannot write 9p3. Why? Because 9p3 in this case will have a different answer. Why? Because that means you're only arranging those 3 people. The remaining 4th person is not arranged in the log. So that's wrong. So you first do the selection and then once you have done the selection, you arrange all of them together. What will happen if I say one person never occur? One person never occur.
Nine C4 4 factorial.
Perfect, works. You can directly write permutation here also. One person is not even considered. So I don't have total 10. I have a total 9. And now I have 4 of them. So you can select together and arrange also. or you can directly do the selection first and then arrange, any which way. So you can write 9P4 also, or selecting the 4 people and then arranging them. Both of them are correct. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
From 5 vowels and 6 consonants, form a word containing 3 vowels and 3 consonants. What will you do?
First select, ma'am.
Very good. First, from 5 vowels, select 3 vowels. 5C3. Then out of 6, select 3 consonants. 6C3. So you have selected 3 vowel and 3 consonants. So 6 letters. Now those 6 letters, to form a word, I need to arrange. So factorial 6 together. Am I clear?
Yes, ma'am.
Yes, ma'am.
All of you clear? Question. 6 plus sign, 4 minus sign. Arrange them so that no two minus signs occur together. Think. See, plus signs are all identical to each other. It's not person. I haven't given you 6 boys and 4 girls. In that case, it would have mattered which boy is sitting where. Right now, they're all symbols. They're all identical to each other. Right? So first you make all the plus signs sit. So all the plus signs can sit in how many ways? 1, 2, 3, 4, 5, 6. Only one way. Write them. There is only one way. Now, if you want the minus signs to be not together, the minus signs should be in these gaps. How many gaps are there? There are 7 gaps. Out of those 7 gaps, I need only 4 of them. Do I need to select, or I also need to arrange?
Select, ma'am.
Only select, because minus signs, now what will you arrange? They are all identical to each other. So from 7, only select. From 7, only select 4 positions. From 7, only select 4 positions. From 7, only select 4 positions. Am I clear?
Yes, ma'am.
Calculate this. Right. All of them are identical. How do we calculate? There were tricks. NC0 is 1. NC1, only one number. NC2, 2 numbers multiplied divided by factorial 2. NC3, multiply 3 numbers by factorial 3, 6. Now 7C4 can be written as 7C, 7 minus 4, 3. And 7C3 is 7 into 6 into 5 by factorial 3. gets cancelled. So 35 is the answer. Clear? Guys, clear?
Yes, ma'am.
Yes, ma'am.
Any doubts?
Ma'am, don't we multiply 6 factorial, ma'am?
It's a trick. If you are now using the normal formula, then we do that. For trick, you can directly do this.
Yes, ma'am.
If you are using the formula, 7c3 factorial 7, 7 minus 3, 4 factorial 3 factorial. And in this case, no 6 factorial because all the 6 positive signs are identical to each other. So there is no need to arrange them.
Yes, ma'am. Got it, ma'am. Thank you, ma'am.
Okay. Now let's start combination. In combination, we mainly have formulas. Okay. So let's note down all the formulas and then we'll do the sums accordingly. First, NCR, factorial n minus r. We don't really use this. We'll be using the tricks. NC0, 1. NC1, only one number divided by factorial 1, so 1. NC2, multiply two consecutive numbers by factorial 2. Multiply three numbers divided by factorial 3. NCR is same as NCn minus r. For example, 13C10 is same as 13C, 13 minus 10, 3. 8C6 will be same as
C2, ma'am.
next. If two combinations are same, then either they are same or n is equal to p plus q or n is equal to p plus q. So either two combinations would be same or they'll add up and give you the total. From this, we can use the sum. For example, if I say 24CR is same as 24C 2R plus 3. So either R will be equal to 2R plus 3. R is minus 3, which is not possible. R cannot be negative, it's a whole number. Or if you add them, you should get 24. 3R equal 21, R will be 7. Now I can ask you, hence find what is 7CR. 7CR is 7C7. What is 7C7? It is same as 7C0. That will be 1. Clear? Guys, I'm waiting.
Yes, ma'am.
All of you understood? Then fifth. If there are n points, no three of which are collinear, then first number of lines will be NC2, number of triangles will be NC3. If there are n points, m of which are collinear, then number of lines NC2 minus collinear plus 1. And if it is triangle, total minus the collinear part. There is no plus 1 here. 7. Number of handshakes in a party of n people. This will be NC2. Number of hugs, same NC2. Number of diagonals in a polygon of n sides or n vertices. Number of lines minus n. That is n minus 3 by 2 if you open. If you open, then it becomes this. N minus 3 by this. Nine. Number of ways of selecting one or more person out of n people. So every person has two options, included or not included. So total option power n. I have to select at least one. So minus 1. This is basically selecting one or selecting two people or selecting three people till n. It's the same. Suppose I say that I have 10 friends. I want to invite them to a party. I can invite 0, I can invite 1, I can invite 2, I can invite 3. So every friend has two options. Either they will be invited or they won't be invited. So total 2 power 10. But if I say I have to invite at least one person, so I'll subtract the case when I haven't invited anyone, the darkness. So minus. Clear? 10. NCR plus NCR minus 1 consecutive. Then this will be N plus 1 CR. This will be N plus 1 CR. Example. 10C2 plus 10C3, 11C4, 12C5, 13C6. Calculate. If we first apply this formula in these two, it will be 11C3. Then apply in these two. 12C4. Apply in these two. 13C5. What's the final answer?
14C6.
Yeah. Okay. Do the question. 12C4 plus 12C3. Answer.
13C4.
Calculate. It will be 13C4. Calculate this. Calculate this. Through the This is 715. Did you all get this answer?
Yes, ma'am.
If 18C4 is same as 18CR is same as 18CR plus 2. Find RC5. First here calculate. 18 will be equal to R plus 2. 16 equal to R. So R will be 8. Now from here calculate 8C5. 8C5 is same as 8C3. So 8 into 7 into 6 by factorial 3. 56. Clear?
Yes, ma'am.
Problem. Question. There are 8 friends. In how many ways can you invite one or more person to a party? There are 8 friends. In how many ways can you invite one or more person to a party?
254.
It is 2 to the power 8 minus 1. One friend, 2 option, invite, not invite. Second friend, 2 option, invite, not invite. So 2 power 8. But I have to invite at least one. So 0 option is not there. That's why minus. Number of diagonals in a decagon. Decagon means 10 sides. Number of diagonals in a decagon. Decagon is 10 sides. So it will be 10, 10 minus 3 by 2. I gave you the formula. Or 10C2 minus 10. Answer.
35.
35. There are 16 points. How many lines can be formed? If I haven't said anything, that means no collinear issue. How many lines can be formed out of 16 points? Answer, guys. It is 16C2. Calculate. Answer.
120.
How many triangles? 16C3.
560.
560. If I say that out of 16 points, 5 are collinear, then how many lines? It will be total lines minus the collinear ones plus 1. This is 120, this is 10, this is 1. 111.
Yes,
Yes,
ma'am.
ma'am.
How many triangles? It will be total minus the collinear. There will be no plus 1. So 16C3 was 560. This is again 10. So 550. Clear?
Yes, ma'am.
Yes, ma'am.
How many handshakes can be done out of 10 people present in a party? How many handshakes can be done in a party that consists of 10 people?
45.
45.
10C2, that is 45. If I say that number of handshake is 66, find number of people. Options 10, 9, 11, 12. If number of handshakes in a party is 66, How many people are there in the party? Do trial and error. We know that if
Same.
there are 10 people, then there is 45 handshake. If there is 9 people, then there is 36 handshake. If there is 11 people, 55 handshakes. 12, there is 66 handshakes. So answer is 12. Any doubts?
No, ma'am.
No.
No, ma'am.
There are 8 points on the circumference of the circle. On the circumference of the circle. Number of chords. Chords are basically lines. So answer would be 8C2.
28.
Very good.
28.
28. Clear?
Ma'am.
Any doubts still here? Now there are 3 kind of a learn category or a different variety of question, but it is asked in this chapter. First, write them will you same variety as the sum of the digit. Now there was a trick. Similar question. First, number of factors of say 180. So what we do is we first factorize 180. Factorize 180. Divide 180 by 2. Again by 2. So 2 square. Then 3 square and 5 power 1. Can you do that? Can you do this thing? We can do this, right? Using calculator. All of you?
Yes, ma'am.
So number of factors will be add 1 to the power and multiply. Add 1 to the power and multiply. So there are 18 factors including 1. There are 18 factors including 1. Understood? Number of factors of 75,600. How many factors are there of 75,600? So 75,600. Keep on dividing by 2 first. 1, 2, 3, 4. 4 times. Then I'm dividing by 5. 1, 2. Dividing by 3. 1, 2, 3. Then only 7. So number of factors would be add 1 to the power and multiply. Add 1 to the power and multiply. Answer would
120.
be 120. Clear? All of you clear?
Yes, ma'am.
Yes, ma'am.
Then question. First is number of ways in which 15 mangoes be divided equally among 3 students. So first, 15 mangoes. They are all identical to each other. It's a fruit, right? If there would have been people, then it would have mattered. The next question will do that. If it is a non-living thing which are identical, plus sign, minus sign, fruits, in that case, the formula is total factorial divided by share of each person to the power number of persons. Only in the case when the number of the object that you are talking about is identical in nature. Only in that case. In that case, we can use this. The number of people that you are talking about divided by how much will be each person's share to the power number of person. Am I clear this formula?
Yes, ma'am.
So this will be 15 factorial. So if 15 mangoes are divided into 3 people, in that case, what will happen? Every person will get how many? 5, 5. So factorial 5 raised to the power 3. You'll have the same thing in the option. In your option, you won't have a calculated one. You'll have the same answer. Clear?
Yes.
Share of each person is in factor 10. Now, if this would have been people, then we can normally do it. What will happen is, say, number of ways in which 12 students be equally divided among 3 groups, whatever. Formula total factorial share of each group, same formula, to the power number of group, number of team. This much is same into factorial number of groups. This is extra. So it is 12 factorial. Every group will have how many people? 4 people. Factorial 4 to the power 3 into factorial 3. Clear?
Yes, ma'am.
Answer. This is
Yes,
our
ma'am.
answer. Any problem? All of you clear?
Yes, ma'am.
And last, I forgot the formula. Forgot to give you the formula. Number of parallelograms that can be formed out of 7 horizontal, out of say n horizontal and m vertical lines. Yes, horizontal C2 multiplied by vertical C2. Horizontal C2 multiplied by vertical C2. Example, if I have 7 horizontal and 5 vertical, then whether you ask me parallelogram or you ask me rectangle, it's the same answer. 7C2 multiplied by 5C. Answer. Answer.
210.
210. This is 21 and this is 10. So 210. Learn two formulas. First, NPR can be written as N minus 1 PR plus R into N minus 1 PR minus 1. Learn this as a formula. Another, you don't use it in sum. Just remember it as it is. Factorial 2n, 2 to the power n into factorial n into odd numbers. Remember these two sums. You don't use it in any other sum. You just have the same sum as it is. One into 3 into 5 into odd 2 n minus and all the odd numbers. Done?
Yes, ma'am.
Last sum. It's a little tough sum. It has come in your paper earlier. Okay. You have to do this sum earlier. Otherwise, it's difficult to know. Question is, in how many ways a selection of 4 letters can be done from mathematics? I'll do the sum. See, if it would happen directly, then direct factorial and all those things. Problem is how to select 4 letters. So I can have for 2M, 2A, I can have 2T, right? Or I can have 2M and 2 single letters, or I can have all 4 single letters. So in mathematics, there are total 12 letters in which there are 3 groups, 2M, 2A and 2T. And there are 5 single letters. Sorry, 11 letters. So selecting 4 letters, case 1, I can have 2 groups. I can have 2M, 2As. I can have 2A, 2T. I can have 2M, 2T. So out of 3 groups, I need to select 2. As soon as I select 2 groups, I have 4 letters. 2, 2. Do you all agree?
Yes, ma'am.
Now 3C2 is basically 3. Case 2. I can have 1 group and 2 distinct letters, separate letters, single letters. Can I say that?
Yes, ma'am.
So select a group. In how many ways can I do that?
3C1.
3C1.
Now, see. I have selected a group. Say I have selected 2 M's. I have selected 2 M. Now I need another single letters. I'm not allowed to have a repetition, but I'm allowed to have 1 A. I'm allowed to have 1 T, right? I can have them once. I cannot have them twice. So I have these 5 single letters. I can also have 1 A and 1 T in my selection. Do you all agree?
Yes,
If I
ma'am.
have selected 2M as my group, then from the remaining group, I cannot have 2, but I can have 1, right? So I have a total 7 single letters, and from those 7 single letters, I need to select only 2. Do you all agree this?
Yes, ma'am.
So 3C1 is 3, 7C2, 21. So total 63. नहीं ले सकता इसीलिए तो एक टी लिया मैंने. Case 3. All 4 distinct separate letters. Can you tell me what will this be? I have a N, A,
8, 3, 4.
T, H, E, I, C, S. I have these 8 single letters. Out of these 8, I can select any 4. I can select any 4. Do you agree?
Yes, ma'am.
This is 280. Sorry, 70. So total 70 plus 63 plus 3. That is 136. In total, 136 possibilities are there. Clear?
Yes, ma'am.
Any doubts?
No, ma'am.
These are all the concept of the chapter. Only the concept. Now we'll do the past year questions. Okay, 6 points are on a circle, the number of quadrilaterals that can be formed. Quadrilateral geometrical figure, so combination, it will be 6C4. What is 6C4? 15. The number of ways of arranging 6 boys and 4 girls in a row so that all the 4 girls are together. So for together, form a bundle. 6 and 1, 7 factorial, and the bundle will also be rearranged. Option C. How many numbers not exceeding 1000? That means the number can be 1000 or smaller than 1000. That can be made from the digits this if repetition is not allowed. So smaller than 1000, that means the number can be a 1 digit, 2 digit or 3 digit. So how many 1 digit numbers are possible? 9. How many 2 digit numbers? Repetition is not allowed. So 9 into 8. How many 3 digit numbers are possible? 9 into 8 into 7. 504. So final answer 585. Does it match? A garden having 6 tall trees in a row, in how many ways 5 children stand? One in a gap between the trees in order to pose for a photograph. So there are 6 trees, right? And in a row. So 1 tree, 2, 3, 4, 5, and 6. One in a gap between the trees. So how many gaps are there? 1, 2, 3, 4, 5 gaps. 5 gaps and 5 children. Factorial 5. 120. 15C3 plus 15C3. If question is wrong, it will be 15C2. So it will be 16C3. In how many ways a team of 11 players can be made out of 15? One particular player is not to be selected. That means we have only 14 players. Out of 14 players, we need to select 11. Since it is team formation, so it is a combination. 14C11 is same as 14C3. So 14 into 13 into 12 divided by 6, 364. Find the number of arrangement of 5 things taken out of 12 in which one particular thing will always be included. So first we select the remaining 4. Out of 11, select the 4 and that one person. So total 5 and then 5 factorial. 39,600. Any doubts?
No, ma'am.
In how many ways 3 prizes out of 5 can be distributed among 3 brothers equally? That means 3 prizes need to award it. Prize, so it matters. 5, P, 3. 60. First prize can be awarded in 5 ways, second prize can be awarded in 4, then the third. पांच में से 3 है ना, छोड़ना भी normal. 12 questions are to be answered as yes or no. How many ways are there? Every question has 2 options, so it will be 2 to the power 12. 4096. The letters of the word violent are arranged so that the vowels occupy even places. Violent has 7 letters, 4 even position. Second, fourth, and sixth, 3 even positions. How many vowels are there? 3 vowels. 3 vowel, 3 position, factorial 3. The remaining 4 consonant, factorial 4. 6 into 24, 144. Any doubts? Trial and error. Answer. See, this is wrong, this is wrong. Answer can never be negative. Answer can never be negative. -2 can't be the answer. Right? So try for 7. If 7 is true, 7p4, 20 times 7p2. If that is the answer, then yes, otherwise none of these. 7p4, factorial 7 by 7 minus 4, 3. This is 840. Same. 840. So 7 is true. Next. A man has 3 sons and 6 schools within his reach. In how many ways can he send them to school? No 2 of his sons are to read in the same school. So out of 6, select 3 schools. 6p3. 13. How many permutation can be formed from the letters of the word drought if both vowels may not be separated? So A and U will be sitting together. So how many? 1, 2, 3, 4, 5, 6. So factorial 6. And they have to be together. The arrangement is not fixed. So factorial 1440. Answer. See this one, 13C6. It is twice. So I can write it twice. Plus 13C4. Here applying the formula 14C6. Here applying the formula 14C5. Again applying the formula 15C6. So X will be 6. 14, 14, same, 5 and 6 consecutive. The total number of handshakes. So 10C2, 45. Direct formula. Diagonals. Formula was n minus 3 by 2. Trial and error. Answer. Answer is 11. (17) In how many ways can the word article be arranged in a row so that vowels occupy even places? Same 144, we just did violent. Different words can be formed with the letters of the word liberty. Liberty, 7 letters, 7 factorial. 504. Rearrange नहीं लिखा. In how many ways a family consists of 3 children have different birthdays in a leap year? So the first child can have 366 options to choose his birthday. Whichever date this first child has chosen, the second child cannot choose the same birthday. So the second child will have 365 options. Whichever date these two have chosen, the third child cannot have the same day. So the third one will have 364 options. So option A is the correct one. So either 3r is equal to r plus 3 or 3r plus r plus 3 is 50. This is 2r equal to 3, r 3 by 2, not possible, fraction. 4r equal to 12, r will be 3. 3 is the correct answer. 6 times the number of permutation of n item taken 3 at a time is equal to 7 times the number of permutation of n minus 1 item taken 3 at a time. Trial and error. Answer 21. Do trial and error. That's the only option. 22. For us to apply formula, this is wrong. This is 98. So this will be 999. This has to be 999. Trial and error. Option A, 4. 5 books of English, 4 of Tamil and 3 of Hindi are to be arranged in a single row. Same language come together. So form bundle. 5 English book, 1 bundle. 4 in Tamil book, 1 bundle. 3 Hindi book, 1 bundle. 3 bundles. So factorial 3. The first English bundle can arrange among themselves in factorial 5 ways. The second Tamil bundle can arrange among themselves in factorial 4 ways. The third Hindi bundle can arrange among themselves in factorial 3 ways. Answer is C. 5 boys and 4 girls are to be seated. The girls occupy even places. So 9. So there are 4 even places and 4 girls. So factorial 4. Remaining 5 factorial 5. Option D. A person has 10 friends, of which 6 are relative. He wishes to invite 5 so that 3 are relative. So out of 6, invite 3. 6C3. Remaining 4 friends. 4C2. Multiply them. 120. A student has 3 books on commerce, 3 on eco, 5 on commerce. They are to be arranged subject-wise. Then subject-wise means they have to be together. So form 3 bundle. So factorial 3. Then the computer can be arranged, eco can be arranged, and commerce can be arranged. 25,920. The number of 4-digit numbers that can be formed from the 7 digits so that no digit being repeated and they are greater than 3,000. If I want the 4-digit number to be greater than 3,000, the first place has to be filled by 3, 5, 7, 8 or 9. So there are 5 ways to fill this position. Remaining 6, then 5, then 4. Answer 600. A question paper consists of 10 questions, 6 in math, 4 in stats. Find out number of ways to solve the paper. At least one has to be attempted from each. At least one has to be attempted from each. So every question. So yeah, all the 6 questions has 2 options. 2 to the power 6. But I have to answer at least one. So -1. Same goes with stats. I have to answer at least one. You could have also done different cases. That's your answer. Cases. 1 from here, 3 from here, that's so many. Answer is 945. See, there are several possibilities. You are answering one math question, 4 stats, one math question, 3 stats, one math question, 2 stats, one math question, 1 stats. and then the other way around again. It's extremely long. There are 6 gents and 4 ladies. A committee of 5 is to be formed that needs to include at least 2 ladies. So out of 5, I can have 3 gents and 2 ladies, 2 gents and 3 ladies, 1 gents and 4 ladies. So 3 gents, 6C3 multiplied by 4C2 or 6C2 multiplied by 4C3 or 6C1 multiplied by 4C4. Calculate. 186. You can divide, we did the sum. NPR divided by NCR is factorial R. So 6 equal factorial 3, R will be 3. 10 students in a class including 3 girls. So out of 10, there are 3 girls and 7 boys. Number of ways to arrange them in a row when any 2 girls out of them never come together. Any 2 girls out of them never come together. What will happen? So 7 boys, that means 7 factorial. Out in the 7 boys, there will be 8 places. Among those 8 places, you can select any 3 places for the girls. So 8P3. We did a 4 boys, 4 girls question. In how many ways can a selection of 6 out of 4 teachers and 8 students be done, including at least 2? So out of 6, I can have 2 teachers, 4 students, 3 teachers, 3 students, 4 teachers, 2 students. So 2 teachers, 4C2 multiplied by 8C4, 4C3 multiplied by 8C3, 4C4 multiplied by 8C. Answer 672. Maximum number of points of intersection of 10 circles. What will happen? How? To intersect 2 circles out of 10, each circle will cut at 2 points. So 10C2 into 2, 90. How many numbers between 1000 and 10,000? Between 1000 and 10,000 means a 4-letter word that can be formed out of this. So basically 6P4, 360. This is learned. It is there in your book also. Learn. You cannot do. It's a huge sum. And if you cannot remember, leave. Doesn't matter, leave. 37. 4 members can occupy 9 vacant seats. Answer 9P4, 3024. 9 seats are there, 4 have to be selected for the members. Since they are human beings, it will matter who is sitting at the corner of which. The number of arrangement that can be formed from the letters of the word Allahabad. So Allahabad has how many letters? 9. Out of that, how many are repeating? There are 4 A's and 2 L's. Answer 7560. Same sum. 10C3, 10C4 can be written twice plus 10C5. Here answer is 11C4. Here the answer is 11C5. 12C5. So answer would be 12. Answer would be 12. The number of parallelograms. So parallelogram was 6C2 multiplied by 4C2. 90. Trial and error. Trial and error. It's 15. 42. Repetition. Repeat some. So 3 bundles basically. Factorial 3. Then each bundle can arrange among themselves. Computer, commerce, and eco. Answer C. 43. Repeat question. Answer would be 12C3 plus 2 times 12C4 plus 12C5. This is 13C4 and this is 13C5. So 14C5. So X can be 5. But 14C5 is also same as 14C9. It can also be 9. Number of ways in which a man can invite one or more of his 7 friends to dinner. So 2 to the power 7 minus 1, 127. The number of words from the letters of the word Bharat in which B and H will never come together. Total minus together. So total is factorial 6 minus together. Together will be B and H form a bundle. Factorial 5 into factorial 2. So 720 minus 240. Oh, my fault. My fault, my fault, my fault. There are 2 ways repetition. You forgot that. So first is factorial 6 by factorial 2. Then bundle. So factorial 5 by factorial 2 into factorial 2. 360 minus 120. 240. Answer. So n will be factorial 9 by factorial 7 plus factorial 9 by factorial 8. This is 9 into 8. Factorial 7 gets cancelled. This is 9. 72 plus 9, that is 81. Factorial 9 goes to the left side. We did the same sum. Repeat. R will be 3. A bag contains 4 red, 3 black, and 2 white balls. In how many ways 3 balls can be drawn from this bag so that they include at least 1 black? So total minus 0 black. That's easier. So total how many balls? 4 plus 3, 7 plus 2, 9. Out of 9, select 3 balls minus when there is 0 black ball. Minus 63. Answer. $64. So either x is equal to 2x minus 4. So x is equal to 4. But it has said that x cannot be 4. Or if I add them, I should get 11. 3x equal 15. So x will be 5. We have to calculate 7C5. 7C5 is same as 7C2. 7 into 6 by 2, 21. Last question. Which of the following is a correct statement? Option A. You can do trial and error. Put n equal to something and you can see which one gives you the same answer. So that's the end of permutation and combination.